Hello everyone, today we're going to learn how to draw distance time graph, acceleration time graph from speed time graph in three different contexts: constant speed, increasing speed, and decreasing speed. So let's take a look at constant speed first. So you notice that constant speed on speed time graph, right? The speed is constant rate, okay, fixed. Okay, so how do we draw and represent on the distance time graph? Okay, we all know that the speed on the distance time graph is actually the gradient of the graph. So I know that since I'm having constant speed, my distance will increase at a constant rate. So it looks something like this, constant rate. So if I want to find out the speed, right, likewise, if I want to know the exact speed, I can just take any value here, right, the rise over the run, and I get the value. Let's say this is like maybe 100 meter, this is like maybe 10 seconds. I can take 100 over 10, I get 10, and I know this is my speed over here, which is 10 meter per second. Okay, so if I want to know now the acceleration, okay, I know that right now from the speed time graph, my gradient, okay, is 0, right? And I know my gradient is 0, my acceleration actually represents the gradient of the graph. So since I know it's 0, my speed is fixed. I'm not increasing the speed, I'm not decreasing the speed, means I'm not having any acceleration, which means it's 0. So it looks something like this. Let's take a look at the increasing speed now. Okay, so my speed is increasing this way. Alright, so how do I represent it on the distance time graph? So notice that my speed is increasing. At first there's less distance. Okay, I'm starting slow. And then over time, as I increase the speed, right, there will be more distance covered. So how it look like is something like that. And so how I remember also is that slope is more gentle to more steep. Okay, since the speed is slow first and then gets faster and faster, so the gradient will be from more gentle to steep. So since we know that the acceleration is the gradient of a graph in the speed time graph, I can look at the speed time graph. I notice that the gradient over here, right, the gradient here is actually a positive gradient. So if I calculate gradient, I can have the acceleration on the positive value above the horizontal axis. Let's look at the last context, decreasing speed. Notice that the speed now is decreasing. Okay, right? So it means when speed is decreasing, right, at first there's more distance covered, and then over time there's less distance covered. So then how to remember also that since the speed is decreasing, it means at first it's more steep, right? The gradient is more steep, right? There's more value in the gradient, and then the gradient gets lesser and lesser, right? And then it becomes more gentle. Finally, right, if I want to know the acceleration time graph, I notice that the gradient here is negative. Just now it was positive. Okay, and then if I calculate the gradient, I'll know my acceleration time graph is below the horizontal axis. So that's how we do for the speed time graph, distance time graph, and acceleration time graph for these three different contexts.